Hello, my dear students. Welcome to 8th Standard Mathematics. Today, in this first class, we are going to learn or understand the different number formats. As you can see on the screen, the numbers starting from 1, 2, 3, 4, 5, 6, etc. We call it as a counting numbers or a natural numbers. Let us take this equation x plus 2 equal to 13. When we solve this equation, we get the answer as x is equal to 11, which is nothing but the solution of this equation. When you put the 11, only 11, this equation we can solve it. The 11 here is a natural number. We can see this circle, pink circle. This represents the natural number. Let us take this collection of numbers 0, 1, 2, 3, 4, 5, etc. What we call it as? We call this as a whole number. Let us take the equation x plus 5 equal to 5. The solution of it, or the answer of x, the solution of x is equal to 0. This equation only satisfies for the value of x equal to 0. So x, the 0 here is the solution. For solving this equation, we need 0 as a solution. So we need a different number other than the natural number 0 for solving this equation. So here the 0 is a whole number. You can see this green color circle, which also contains the pink circle. The green color circle represents the whole number, which also contains the numbers, all the numbers. The pink circle, which represents here the natural numbers. And my dear students, the numbers which is having negative sign, 0, and the numbers which is having positive term, together it makes a collection of integers. Let us take this equation x plus 18 equal to 5. When you solve this equation, we get value of x is equal to negative 13. This equation can be solved only by the negative number 13. So here 13 is a integer number. Let us take this yellow circle, which represents the integer. It is denoted by the letter Z. Z means, it stands for the Greek word zalen, which means to count. This yellow circle contains the whole number circle, green circle, which represents the whole number, and the pink circle, which represents natural number. Natural number represented by the letter N, capital letter N, and the whole number is represented by the capital letter W. The numbers which is in the P by Q format, we call it as a rational numbers. Here the numerator and the denominator P and Q are integers. Let us take the equation 2x equal to 3. Here, the solution for this equation is 3 by 2. Let us take another equation, 5x plus 7 equal to 0. When you solve this equation, we get the value of x is equal to negative 7 by 5. So this negative 7 by 5 and 3 by 2 are, we can say these two are the rational numbers which exactly solves these two equations. To solve these equations, we need this rational numbers. We can't put any other number in this place of this. We can't put a whole number or a natural number here to solve these two equations. Here you can see the red circle which represents the rational number inside that yellow circle which represents the integers, green circle which represents the whole number, and we can see the pink circle which represents the natural numbers. So from this one we can understand that rational number which contains integers, whole numbers, and natural number, everything is collection. We together all the collection we say it is a rational numbers. So we are learning about rational number. Our chapter name is rational numbers. You have learned the chapter about rational numbers in 7th standard. You have learned how to add to rational numbers, subtract, multiply, and divide. Let us take two natural numbers 2 and 3. When you add these two numbers, we get 5. 5 is again a natural number. So we can put that inside the pink circle, because when you add that numbers, we get the answer also 5. So it is also natural numbers. It is not going out of the pink circle because it is also a natural number. So this we say this natural number, when you add these two natural number, we get the answer also natural number. So it is say we are saying that it is a closed one. We are saying it is a closed because it is inside the answer, it is inside the pink circle. Let us take these two numbers again. When you multiply, what happens? Let us see. When you multiply 2 and 3, we get number 6. Again, 6 is a natural number, so it is not going out of the pink circle. So we can say that the multiplication also here is closed. From this one, we can say that addition of a natural number closed, or we can say that natural numbers are closed under addition. Same way, we can say that natural numbers are closed under multiplication. What happens when you subtract and divide the natural numbers? Let us take the numbers 3 and 2, natural numbers. 3 minus 2. What is the answer? We know that the answer of 3 minus 2, it is 1. The result of 2 minus 3 is minus 1. The answer minus 1 is in the yellow circle, which means it is going out of the pink circle, which is a natural number. It is going out of the circle, so it is not closed, it is going outside. So we can say the natural numbers are not closed under subtraction. When you divide two natural numbers, what happens? We can see that when you divide 3 by 2, when you divide 3 by 2, the answer is, again we get 3 by 2 in a fraction or 1.5. It's a decimal value. It goes to the red circle, going out of, again it is going out of the pink circle. So You can't say that it is a closed, it is going out of the answer is going out of the circle. So here we can say that the division of natural numbers are not closed under division. Now let us take the same closure property. So it is called as closure property of numbers. Let us check it for rational numbers. Let us see it is whether it is inside. When you add two rational numbers, it is it inside the circle? When you add these two numbers, rational numbers, we get the answer also in rational numbers. It is not going out of the white circle. Here the white circle represents the rational numbers. Same way, when you subtract these two rational numbers, the answer is also rational numbers. So it is not going out of the circle. So we can say that addition of rational numbers and subtraction of rational numbers are closed. In other words, we can say that rational numbers are closed under addition, rational numbers are closed under subtraction. Let us multiply these two rational numbers and see the answer. It is also a rational number. So we can say that rational numbers are closed under multiplication because it is not going out of it that rational number circle. What about the division? Check these numbers. When you divide these two numbers, we get the answer also as the rational numbers. Except when you divide a rational number by 0 or any number when you divide by 0, it is not defined. So we can't say that the answer is closed. It is a rational number. When you divide a rational number by 0, it is also, we can't say the answer is a rational number because it is the answer not defined. So it is not closed inside. It's that answer is not closed inside. So we can say finally here we can conclude that rational numbers are not closed under division operation. When you do addition, subtraction, multiplication, division, we can change the numbers or we can interchange the number or we can replace or we can change the position of the numbers. For example, when you add numbers 2 plus 3, we get the result as 5, the same as when you change the position of 3 plus 2. Is also the answer same. So when you get the same answer after changing the numbers position, if it is the answers are equal, this we say is that operation are commutative. Here we used natural numbers, so the natural numbers, addition of natural numbers are commutative. Changing the numbers position, we say it is a commutative property. Let us check it for multiplication. You can see here when you multiply 2 into 5, it is same as 5 into 2. So we can say that the natural numbers are commutative under multiplication. What about the subtraction? When you subtract 7 minus 5, is it equal to the 5 minus 7? No, it is not equal. So when you change the numbers, the answer is not equal. So we cannot say that subtraction of natural numbers are commutative, or we can say that natural numbers are not commutative under subtraction. So let us take the division. When you divide 10 by 2 or you check 2 by 10, after changing the positions. Are these are equal? The answers are equal? No, they are not equal. From this one, we can understand that natural numbers are not commutative under division. In your class also, we have friends. Friends, usually we have a friends group. We're all in the same class, but we have our own friends group. Like that, here we are taking three numbers, 7, 2 and 5. Here we are saying that these three numbers are not friends when we are adding it. We're going to add the numbers 7, 2 and 5. The first scenario, first we are saying that 7 and 2 are friends here. So that we can put it in that bracket. Why are they putting in the bracket? These two numbers, 7 and 2 are friends. And we are adding it. After that, with the result of 7 and 2, we are adding the number 5. We get a final result. The second time, when you see that they got a fight between 7 and 2. Now, 2 and 5 are friends. Okay, 7 is not in that group. Okay, it is standing separately. This time we are adding 2 and 5. After that, the result we are adding with the 7. When you see that results, the answer are same. They are giving the same answer. So we are doing that grouping of numbers, that association we are doing. After grouping numbers, different groups, when you see the answer is same, we can conclude the natural numbers are associative under addition. So here what we are learning is associative property of numbers, grouping it. What about the other operations? Multiplication, subtraction, division. Let us try the subtraction. 7 minus 2 minus 5. The first time we are grouping 7 and 2 like this. 7 minus 2 in a bracket minus 5. So we are doing what is in the bracket 7 minus 2, subtract it and get a result when you subtract with 7 with 5. The second time, subtracting 5 from 2, that is 2 minus 5. The answer we are subtracting from 7. Is the check whether they are getting the same answer? No, they are not equal. So we are concluding here the natural numbers are not associative under subtraction. Now let us multiply these numbers 7, 2 and 5. 7 into 2 into 5. As we did in the earlier, we are grouping up the 7 and 2. After multiplying 7 and 2, we are multiplying 5 with that. We get a result. Second time, now we are grouping 2 and 5. 2 and 5 friends here. The same example. Now 2 and 7 fighting each other. So 5 and 2 joins here. They are in group. Now we can multiply 2 and 5 inside what is in the bracket. They are in a group. They are associatives. So they are in the same association, we can say. So after multiplying 2 and 5, we can multiply with 7. We get a result. Are they same? Yes, they are equal. So when you change the association, after changing it, after changing the group, if we are getting the same answer, we can say, conclude the operation here we did in multiplication. So multiplication we did with natural numbers. So natural numbers are associative under multiplication. You can see here the division the same way. You can check the results of both the divisions. Are they same? They are not same. Okay. So we can conclude from it the division of natural numbers. We can say, in other words, natural numbers are not associative under division. So far we have seen the associative property for natural numbers for understanding purpose. This is in the same case we can take it for rational numbers. So rational numbers, when you grouping it, it is for addition. So rational numbers are associative under addition. Rational numbers not associative under subtraction. Same way, this rational numbers are associative under multiplication, but the same rational numbers are not associative under division. Same case we can give it for it. Let us summarize what are things we learned now. We have learned three properties of numbers. One is closure property. You can see the circle. When it goes, when you do addition, multiplication, subtraction, when it goes out of the circle, then we say it is not closed. If it is inside the circle, we say it is a closed. Then we have learned about the commutative property, changing the numbers positions. Then we have learned about the associative property, which means grouping in numbers.